Hey, everybody. Welcome to Monday Night Live in Lexington, you guys. Let's get all these streams going. And I'm going to get Twitter on here also if I can. Because sometimes Twitter and Instagram do not cooperate on my phone. So I'm going to try to get this camera turned around. Yeah, move that however you want.
There we go.
So tonight we're going over the science of the plasma electric universe with Sifu Karega here. Thank you for joining me tonight.
No worries.
So special. And, you know, we're going to be going over a lot of other stuff in the future because I had a few fans ask about, and we had discussed this once before. I had a few fans ask about, you know, why they wake up at certain hours in the night. And, I wanted to kind of merge, you know, my study of stuff along with yours and see if we have any correlation. So that's coming in the future. So you guys are just going to have to wait. So let me do some shout outs here. Hey to Melissa Begley and Miss Cleo. I love those two. Hey to Jennifer and Jasmine, Jadoon, Jane, Tommy, Larry, Evelyn, Tom Hansen and Samantha. Nice to see you guys. Oh, yes, I love Miss Cleo and Melissa. They're two of my favorite girls. Samantha Taylor, Gina, Brandy, Amanda, Joe, and Nat, thanks for joining tonight. And hey to all you guys on Instagram over here. Now, just to let you guys know that I can only see the comments on my personal page, and I can't see the comments on Instagram, sorry.
Right.
But I do go back and answer all the questions that you guys post on the comments section. So if you're on my personal page or on my professional page, I promise you I'll go back and answer those comments. Thanks for the hugs and kisses back to you guys. Thank you for coming on the show again tonight, and I can't wait to do more shows too.
Yeah, we're going to get into the really fun stuff.
I know. So we got to get going tonight. So
I tell you.
I had gotten into the theory of dark matter on one of my previous episodes, and boy, did I go down the wrong path.
No, it's not exactly, because you're talking about a different subject, really. You know, dark matter was always, in terms of physics, it was only a darkness in terms of they couldn't see it, and they couldn't see it because it wasn't there. Nothing wrong with talking about things you can't see. Okay, you know, there are multiple dimensions.
I thought it was so much more, and then
well, the thing is that there were just better theories. They recently discovered that half of the matter that they were looking for was baryons, which for people, I have here the definition of a baryon. It's a composite subatomic particle made up of 3 quarks. All right, so this is the list of quarks. Well, these are the quarks. You can see the electrons down here in what's called the leptons.
Hold that up a little bit closer for them.
So quarks, now if you look carefully, you see where it says, for example, the down quark is so many mega electron volts per c squared. That's what's called a charge density. So all of the quarks and leptons, what we're talking about are charges. So it turns out it's electric anyways. And that makes sense because when we talk about when you get into high enough physics and you start breaking things down, you no longer talk about like billiard balls, right? You're talking about waves, you're talking about flux, you're talking about current and charge density, and these are the things that are really governing the universe. So, you know, it says here the Higgs boson is 125 giga electron volts, so it's 125 billion, whereas the electron is only 500 kilo electron volts. So we're talking about a different level of charge density, which ultimately comes down to mass.
What does this mean to people that don't understand this kind of
thing? Okay. Here's what it really means.
It's a wave.
Yeah, here's
It's
what
a wave.
here's
That's
what,
the most important thing, is that it's a wave.
what people need to understand, like about the new revelations about the graviton, the gravity wave. They're not gravity waves. They're remnants of electromagnetic waves. When you read into it, they're observing a dot and there's an explosion. They have a theory and a model behind how that happened, but they really only see this dot and it's lighting up, and then you get remnant radiation.
Mm-hmm.
And then you measure that and you assign them to, they are looking for certain wavelengths. And the graviton and a lot of these other quarks are really just current best models. It's sort of like how at one time the four elements were the best model, and then the atom, and then the 3 particles, the subatomic particles, and then there were quarks below those particles.
Mm-hmm.
And all science is a continuous movement towards better models.
Yes,
So
and
one
we're
time Newton was
constantly
better,
improving
and now
this.
he's not better.
Yeah.
Right. So right now, the quarks and leptons and all that, that's just the current best model. So it's not that anybody, maybe science did a boo-boo in trying to create almost a faith of dark energy and dark matter.
Mm-hmm.
But it turns out the dark energy problem is a separate problem. That's a problem of they don't understand redshift, despite Houghton Arp telling them what redshift was. Dark matter was more, they needed something to explain why galaxies rotate the way they do. They needed more mass.
Mm-hmm.
It turns out they had plenty of mass, but they didn't have was an understanding of plasma physics. As astronomers just didn't understand plasma physics. But you can produce all the rotations of the gravity you need, or of the galaxies that you need,
Mm-hmm.
from plasma physics. So
yes, and that's explaining a lot of stuff now.
it is.
Lucky us.
Yeah, and it's coming about in the right time. Walt Thornhill and them just released a video, and it's like countering the gravity wave thing, but it's about the black hole and LIGO and about the math, but there's going to be a 2-parter. So I expect the second part, he's going to go over the basic mundane fact of electromagnetism that they are forgetting, and then they're finding it in this electromagnetic. And the thing is, it makes sense. I mean, if there are explosions all over, we should have detected them already. So it's just there's a lot of interference. But anyways, I'm not here to argue with Nobel Prize winners. I just want people to understand that at the deep level, quarks and leptons are all charges. It's just charges.
They're charges.
So the question is, and this goes back to what you were in about, really, positive and negative energy, yin and yang.
Yes.
Right, and then you can also divide that into yin and yang. So there's true black and then the dark black.
Yes.
You know, there's people need to understand that when they get into the world of energy, of you know, us woo
This
energy.
is a rabbit hole we could go down for another 100 years.
So anyways, let's step through the, today we wanted to start with Birkeland current. So what I need people to understand is, hello Jennifer, is that there are electrical currents and then there are Birkeland currents.
Did you pull up Birkeland currents on your phone?
Yeah, I did pull
Let
up
me do some shout outs while you're doing that. Okay, let me go back because I missed a few people. Woo, let's see. Oh my gosh, I'm so far behind. Okay. Hey to Gina and Brandy and Amanda and Joe and Nat. How are you? And Bruce, Stephanie, David, Heather, Janet, Bud, and Ethel. Thanks for joining tonight. Tessa, Zoe. Hey, Zoe. Rhonda, Teresa, and Dale. Thanks for joining us, Dale. And Belinda and Tessa, Jen, John, Ledge, Amy Butcher, Jennifer, Wayne, and John Philip Young. Hey to you. Pamela Downey, Alexandria. Hi to all you guys, and thank you so much for joining. And if you enjoy these Monday night episodes, hit that share button right now and share this with your friends. And hey to Corey Southworth and Arwen. Kisses, Arwen.
So I pulled up the Birkeland current. So a lot of people are more familiar with circuitry, you know, resistors and voltage sources. So this is what a Birkeland current looks like. Here's this, and here's this. So what you can see is that there are currents and they're moving along, and then they have magnetism going around them. And then what happens is they reach a certain affinity for each other, and they start to twist around each other. And this is why we see
making a helix.
Right, and this is what we're seeing with the sun, with its very crazy electromagnetic currents that are going all around, and they wrap it. If you're wondering why, it's because of Birkeland currents. And they found these in the Van Allen belts in the Earth. I mean, this is well established. And they go, when you look from the north of Jupiter, you guys can Google it in the other window. When you look from the north, you can see the clouds of Jupiter rotate and counter. It looks like a complex clock where one set of rings is going in the opposite set of other rings, up to 15 layers.
Fabulously interesting.
That's Birkeland currents.
Yeah.
So the Birkeland currents are really the way that galactic energy is being transferred. And remember our premise that the electric field doesn't degrade in the same way that the magnetic field does. And the electric field, as long as you have two charges, you're going to have an electric field between them. Now, the electric field strength will drop over distance, but with magnetism, you know, it's like it goes away. I mean, everybody's familiar. You get two magnets close together, but over here, nothing hardly.
Right.
You can still measure it, but with electric currents, you can move electricity along massive pathways. I mean, they're finding galaxies lined up, you know, from a side profile view, 6 of these galaxies in a row. It's impossible statistically for it to be all random, and gravity and accretion pulls it together.
Right.
They're moving along filaments, and those filaments, there are a few words that you get used to when you study the electrical universe. You know, you got dendritic, you've got filamentary, you've got scalloping of when you talk about machining, and there are all these different ways that electricity behaves that we're not used to on a macro level because we just don't encounter it. But when it happens, people are weirded out. When they see ball lightning, when they see UFOs that, swamp gas that came out of the water, assuming it's not actual aliens, but it's just unidentified. There's that very famous one in Norway where there was a spiral, and then there was a spiraling light. It was perpendicular to what was coming out. Well, that lab was doing some kind of electromagnetic experiment. That's all it is.
So you could Google, like not Google, but you could search those electrical movements on YouTube and probably find a video that would show you how the electricity acts.
Yeah, there's not a lot of great education for the public on plasma physics. There are a number of textbooks, of course. They're thick. Okay. However, there are some, when it comes to the geology that we're going to talk about tonight, there are some great examples on MR2, the number TUFF2, Mr. Too Tough 2, and he sets up.
Is that a YouTube channel?
It's a YouTube channel, and he sets up, you know, like 2 electrical plates, an anode and cathode, and you can watch what happens, how matter interacts with the electric field, and you have to understand these are electric fields, not magnetic fields. So there are definitely some really cool things that you can study about. I mean, for example, I just got this in the mail today. Look at this fulgurite.
This is so cool. Now, I have a piece of fulgurite, but it's only like that big, and it's solid. This, I think, is ultra fascinating because it's hollow, but not only that, it is slick as glass on the inside.
Which it is glass. That's exactly why.
Right.
Yeah.
But you know, I've not seen that before because all I've seen are specimens that were solid. Yeah. So that's an extra special piece, I think.
Yeah, and as I move forward and create a lab, I'm actually going to try and make different types of fulgurite because there's other fulgurites. So the most, the largest fulgurite.
How did that get hollowed?
It just means that the charges they moved.
The charge was
around,
so strong that it
moved around.
pushed the sand out.
Right. There could have been something in the middle where it had a decreased conductivity. And so, of course, electricity is going to follow the most natural pathway. The thing is, let's talk about meteorology because it came up again. Ophelia. Nobody expected this hurricane. I looked 2 nights before, no hurricane, no prediction. Then the sun has a number of eruptions really quickly, and then Ophelia forms and then heads towards Spain, and then makes a very wild. I don't know if people saw the red sky that it made over there in Europe, but it's really fascinating to go and look at what happened. So why is this happening? Or, for example, my son, he looked out the window yesterday, and you know there was a front that came through, and he said, that cloud's really low, and you look over, and not only was it low, it was completely gray, as if it was a thundercloud. It wasn't a thundercloud. So how does that happen? How do you have a small cloud that looks like it's ready to rain, and you've got massive clouds that are way up higher? And then also, how can there be enough wind to keep them up And at the same time, the fact is, with Bernoulli's principle, if there's a moving fluid along this way, like wind, high wind underneath, well, that's going to have lower pressure inside the fluid. It actually, the air above would push it down,
right,
not keep it up.
Right.
So it has to do with charges, and when clouds have different types of charges, they behave differently. I've seen clouds here in Lexington. You got one set of clouds going this way and another set going this way. I've even seen them going the exact opposites of each other.
It's fascinating to actually watch some of this stuff happen.
And these layers of charges, they can be different from place to place. In feng shui, of course, we know that different rooms can have different feeling. Different houses, even next to each other, can have different feeling and almost different karma, where different people move into the homes. It's like this home is always something bad going on.
Yeah. And
this home, everything looks great. And they can be right next to each other. It's no big deal. And you can experience this in towns. I mean, I can tell you which towns. My Kentucky project, I can tell you which towns have bad energy in them.
Oh, yeah. Which places
I would never buy.
In the earth, in the world, have bad energy, and historically have always had bad energy.
So this just goes to show you, I mean, that the charges are going to move where there's least resistance. Basically, this is
that's
very
an excellent
balanced
specimen.
It is a great pulverite.
So what about star water and star oil?
I know. So the star oil is a big subject. Now the star water, what I want people to understand is that the solar wind. If people don't know what the solar wind is, the sun is constantly ejecting particles and waves in the form of like gamma rays, X-rays, and these particles are, and of course UV and all the spectrum. These particles are bombarding the upper atmosphere of planet Earth. Well, what do we have up there? We've got air, oxygen, right? So and ozone.
Yeah.
So you have O3, which is an ion. And then you've got these other ions coming in. They can bombard, they can mix together and make rain.
Yeah.
And in fact, when
we've got to have it, or we're all going to die.
Right. Well, and the Earth is making more water all the time. If you want to know where most of the ozone is going, it's going away to mix with the solar wind. And we see this on comets. It snows on comets, even though they're tiny and they have no atmosphere. The snow, of course, doesn't fall in the same way as we see here on Earth. It kind of collects in a small layer and then later on evaporates away. And so you'll sometimes take a picture of a comet and it's got like this little sheen, but it's not all of it. Comets are made of rock, in case people don't know, but they're sticking to the dirty snowball. NASA is. It's kind of sad, but it's kind of like that one friend you're like, oh, that's so sad.
You poor thing.
Oh, NASA, come on, you've already disproved it. It's Rosetta. But it'll produce a small amount of water, and then that will evaporate away, and then we'll make more because the comet is evaporating ions, and then the solar wind is hitting it, and they're combining in the comet tail and snowing back down onto the comet.
Right.
So that's where the water. Now the oil is a more complex subject because now we're talking about the Venus effect, right?
Yes.
We're talking about when Earth went through the great comet's tail.
Yes, if you guys, we had talked about the Venus effect, I think in the first one. The first episode that we did about the plasma electric universe. So if you want to go back and watch that, go to my playlist, Facebook Live on Monday night, and you can watch that episode. So let me do a couple more shout outs. Hey to Veronica and Thomas. Hey Thomas. David and Doris, thanks for joining tonight.
So
star oil.
Yeah, well, where do we see the most oil? And why is it there? And why is the environment there? According to ancient sources, Sumerian, Persian, basically the thickness and that region actually glom down on the ground, and people complained about it at some point. And in Sumeria, they were scooping it up and using it, but then it seeped into the ground and became part of the oil, the Earth. The Earth also produces its own oil, so there's some kind of mechanism inside the mantle that we don't understand. Probably the same basic makeup though as what was following in the trail. And by the way, you can still see the plasma trail of Comet Venus. They've actually detected it, and it's still there.
How can you see? Like, if they wanted to go and see that, how can they do that?
I have the paper.
Okay.
Yeah, and so it's in the Mists of Time group, though. I uploaded it into the Mists of Time group.
So
It's
You leave that link in the
Yes, I'll leave
comments for everybody
Yeah,
to
and the Earth has its own
click on.
tail as well.
Mhm.
We've discovered the Earth has its own tail, and its remnant tail is obviously a lot more faint than the one from Venus. So that's what the star oil was.
Wow.
And we talked about the solar circuitry, electric. We did a little bit of meteorology. I wanted to make clear to people this understanding. There are a number of ways you can prove to yourself that storms are electric, aside from the fact that there's lightning. Now that's the most obvious one, but for some reason no one.
It is so simple.
Because they talk about rubbing and they treat it like it's static electricity. It's not static.
No,
it's much more
isn't.
complicated.
It is complicated.
I already mentioned the uplift issue, right? You can't universally uplift. I once saw on the road down at Harrington Lake a section of road where it rained in a 20-foot circle.
Yes.
And it didn't even move.
Yes.
It stayed
and
exactly
you know what?
there.
There are YouTube videos where, and you can go and look them up on YouTube, where it's just raining in like a 6-foot or 10-foot diameter. It is so weird to watch, but it is fascinating.
Yeah, I've personally seen it. So that doesn't go with the standard meteorology.
No.
Another way that you can prove it to yourself is to think about how would hail be held up. They've always told you that it's this uplift. Well, that works when you're talking a 1/4 inch, but when you're talking softball
2
sails,
inch.
I mean, they're getting this big now.
Oh yeah.
I mean, they'll kill you. I mean, these hails have killed people.
They'll kill livestock, ruin your car.
Well, the only force strong enough to do that on a consistent basis and hold up that many on a consistent way, where it's not going up and down, is of course electric charge. And electric charge is quite strong enough to hold it into place. And then
is there any magnetism involved in that, or do you think it's just strictly electric?
Again, when we say the electric effect, it's one force. We're talking
electromagnetism.
Think of this: how Coral Castle? How did he move that stuff? According to Edward Leedskillen himself, the entire world was built of little magnets, and he just flipped the magnets inside of the stones, and then the block levitated because gravity is electric. And the model for that it's better if you go and learn it from Walt Thornhill, because it explains it super well. And there are videos from the Thunderbolts people where they talk about it. But essentially the gravity, you would be feeling more of the electric force, except there's also the opposite side, and it's the net effect which gives you finally this feeling of like a relatively stable amount of gravity. But in the center of the Earth, there's no real gravity. It's just it's opposite charged, on all directions. And we're talking about here is the one force. It's already been unified.
The unifying force.
It's the unified force. It's already been unified. The strong and weak nuclear forces are not separate forces. They're actually just different descriptions of a shorter distance of the electromagnetic force. So when you get down inside of a particle, of course the strength of them goes way up. So it goes from 10 to the 38 times stronger than gravity to 10 to the 39 to 10 to the 40 up to 10 to the 41. So it's one force. So when we say electromagnetic, we mean it's the same. So there's anyway, if you have electricity going this way, magnetism's going this way. That's the right-hand rule.
So I'm thinking this is all this helix that we were talking about earlier.
Well,
on a grand scale.
So in my mystical teachings, I talk about the 8 laws, the Bagua, and one of them is rotation. Everything's rotating, everything's vibrating. Those two laws feed right into each other, from earth into thunder. And so this need of everything to swirl remains. Now, of course, at some time it burns out. So like you have a tornado, you have two massive clouds. Right. You have this huge cloud, and it comes down to a smaller cloud, but it's still big. And then a thin plate, so there's a capacitive effect. And then a vortex comes down and connects the charge from the wall cloud to the ground. And then every once in a while, to keep the system going, because it's an induction machine going this way and a capacitive machine on this direction, so you have storage of potential and storage of current. And then every once in a while, it'll upcharge back to the storm to reset it and to keep going. And that's why you'll see lightning right next to the vortices.
Right.
That's very common.
And that's why it loses its strength over ground, but the capacitor of water increases.
Right, and it depends on...
Or perpetuate.
Right, if it can find new sources of charges, it'll keep going. And of course, certain high winds or something can change that. And there is an effect of humidity and dryness and hot and cold. This is nothing that isn't said in Taoism.
Yeah.
So difference creates a gradient, and a gradient creates potential energy. Potential energy can be converted into kinetic energy, mechanical energy, chemical energy, all the sorts of energy that are constantly transforming. So the electric meteorology actually completely makes sense. If you're wondering how a cloud that supposedly, that little cloud I mentioned probably weighed more than a boat.
Probably.
How does it float? How does it float?
Yeah,
well,
that's a big
question.
question.
Right, it's a big question. How they look fluffy, but people, they are very heavy. Clouds.
They have to be
clouds
to
are super heavy.
contain that much
water.
weight in water.
They're very heavy. And how do they float? And also, how do they float? So, and why do they look different? Because the charge, the way that charge spreads out and equalizes, will be different. And so, this idea of layers, this idea of a separated striata, is really the energy. That's the interesting thing. Having to go back and explain it, it's sad. It's like 100 years later, we still don't get it. No. Because they were talking about this stuff in Tesla's time, you know, and
we're getting there. Though.
We're getting there, but at the same time, we've invested a lot of money in things to go down a path of kind of just imagination, and this
like
stuff is absolutely right.
A lot of money was invested there.
A lot of money has been invested there, and a lot of careers are going to go down. But you know, most of those people, they're gonna come back and say they knew all along. But anyways, it's okay. But the main thing is that we start to use this to help each other. That's why I'm going to be doing my experiment in my clinic, phase 2. It's going to be all electrical. It's a hypothesis. I'm actually. Oh, but it could be the most important. I'm really proud of my Giza stone mover. But I'm way more proud, and I'm really proud of the Megafauna extension.
Are you putting all this on your YouTube channel for us?
I can't put I can't put that on there yet. But it could be. It's one more step closer to my goal of a machine that you can get in, and it reads you and helps you to heal as well, and then helps the practitioner heal in a more universal method. Because it's really sad. The medicine I practice, being state of the art, is 5,000 years old, at least.
Yes.
They found a needle that wasn't used for sewing that's 20-some thousand years old.
Oh, that is so cool.
Yeah, they found that in Central Asia.
For those of you that are joining late, you didn't know, Sifu is an acupuncturist here in Lexington, and you have a clinic in Elizabethtown and Berea.
No, we don't have a clinic in Elizabethtown.
Okay,
just
so
Berea. Yeah.
Blue Lotus Acupuncture, I highly recommend it for any of you with, you know, like chronic, long-term stuff and acute stuff as well. So, catastrophic geology. What in the world?
I'm going to lose some people, I tell you, because, you know, when you talk about things like the Ice Age and you talk about the Grand Canyon, we've been inundated by certain levels of belief. Let's start with the Grand Canyon, okay? Here's the problem with the Grand Canyon. If you go look at a picture of the Grand Canyon, you're going to see straight sides, then V side. Right?
Right. I mean, we can all see that on pictures.
The V is the normal valleying created by the movement of water.
The water.
The vertical sides that are often miles apart.
Away from the water.
Well, it's their theory was that it was supposed to wiggle back and forth. Well, we see that at the Red River Gorge. What happens? You don't get valleys that are miles and miles apart, right? Because the Colorado River is not actually that old. I don't know if people know that know this about the Kentucky River, but it is, the riverbed itself is the second oldest riverbed in the world. The river is not the second oldest, but this riverbed is. And Red River Gorge is also very ancient because we're talking about drainage going back to the end of the dinosaur period with the bays and everything going away. So the question is, what carves the vertical parts of the Grand Canyon? When you look at it from a macro level, it's dendritic. Remember, when we say dendrites, that's not water. Dendrites is electricity.
It's electricity.
Right. Here's another one. Ever since I was a kid, I always thought this didn't make sense. Yosemite, they tell you that Half Dome was made by a glacier going over top of it. I don't know if you've seen Half Dome, though, like even the side, the round part is near vertical. Then they tell you that it cut it in half. So how is that going to be possible? Well, when you look at Half Dome and you look at Devil's Tower, which was not a volcano,
No, it isn't.
it has vertical columnar
It has
formations.
columnar, up and
Because
down striations.
It's fulgurites.
Yes.
And so
It looks exactly like that.
when we talk about Ayers Rock, when we talk about the Stone Mountain in Georgia, even the Cherokee will tell you that was created in this great war of the gods in the Mahabharata, and when there was a constant stream there and it raised an anode blister. It's a form of a fulgurite. The largest fulgurite in the solar system that we know of is Olympus Mons on Mars.
And you know what? Devil's Tower the outside of it looks exactly like that.
And Walt Thornhill, again, has videos of him making not only regular fulgurites in lab, and I'm going to get the 12, you can buy a 12 kilovolt transformer on Amazon. I'm going to get one and make these. But he also makes, and this is going to blow people's minds, instant fossils.
Oh,
and by
cool.
instant, I mean it takes minutes. And this is unconfirmed now, so I can't back this up, but I am looking into it that there was a series of trees in Canada supposedly petrified within hours by down power lines. Now,
wow.
I want to actually confirm
But you know what?
this.
I can see that happening, and I think that
Well,
people they went with their best thought on how these things were formed, but it's just not panning out.
Well, it is, but it's universal. Uniformitarianism is based over long periods of time. From the perspective of an ant, if you step on its hill, that's a catastrophe.
Yeah.
Whereas to us, that's uniformitarianism. So it's a matter of scale, and to some degree, I hate to sound crass here, but the Boxing Day tsunami and the Japanese tsunami, those are uniformitarian events, but to the person who experiences them, they're catastrophic events.
Yes.
So when we talk about catastrophism, we're talking really normalcy in this universe. I mean, planets collide.
Yeah, a lot of stuff blows up.
Right. So there's nothing unusual about it. And as far as
there's stuff happening all the time. We just don't.
There's a boot with a cowboy boot with a petrified leg in it, and you wonder how would that happen? Possibly this transformative effect. I'm not a chemistry major. That wasn't my strength. I tested out of chemistry, but I understand it on the fundamental level of how it works. And it is totally possible that electrical effects would be generating instantly petrified organisms. There's a crab that they opened up this kind of sphere. It's kind of actually an ovoid. And when they cracked it open, there's a crab, and it looks fresh. And when you opened up the crab, its organs were still in there.
Oh my
But it's
gosh.
fossilized. The whole thing is fossilized.
That's
and it fossilized almost as if it. There are mammoths that are also fossilized the same way, where the mammoth's body cannot be distinguished from the limestone that it's in. That's
crazy.
It is crazy.
Crazy, wild, interesting.
It's something that it was also testified by, of course, in the Bible, Lot's wife turning to a pillar of dust, right? So what force is doing this to such a degree that it causes drastic changes that defy our normal sense of how things would work?
Electromagnetic field.
I mean, we just don't know. I mean, in gravity,
I love it.
There's a huge range of things that we just really haven't explored, and we're like children. And if we,
I hope I get to know enough about it before I die.
Well, we're working on it. We're working on it.
Tell me about electric comets.
Of course, comets, asteroids, and meteorites really fundamentally aren't different. That's what the Rosetta mission has proved. There was once a probe that was sent back in like 2000. Well, it was sent in the 90s, but it arrived in the 2000s. Before it arrived, there was a flash on the screen. This was predicted by Walt Thornhill and told to NASA, and they still didn't give him the time of day. However, that flash of light before it hit, then the probe, it sent on a little like grappling hook.
Oh, cool.
No, it bounced off. They thought it was going to go into snow.
Oh.
So then they scrambled. They told everybody that the landing didn't go as planned, that there was a problem, there was a malfunction. But it wasn't a malfunction. It's just that it hit the rock, and they hadn't planned to hit rock. They planned to hit snow. So it didn't send enough force. Luckily, it bounced into place, stayed on the rock, guess what they didn't find? They didn't find snow.
No.
They found rock. And so all this rock is coming from 2 or 3 sources. This is based on world testimony, not Ramon's testimony. I wasn't there.
Okay.
The first would be the Venus-Mars exchange. When they were coupling in the sky, and Mars saved Earth from the wrath of Athena when she became this Medusa character.
Yes.
There was actually discharge going between them, and this is what the Kentucky petroglyphs show, the Haida petroglyphs, all of them, they show this.
Show that correlation between
right.
the
Valkyries that were in Valhalla around Mars, these Valkyries that would bring destruction on the enemies of this warrior god. So that's one source. And that's where the Martian thunder eggs come from. There's also moon eggs that came, and the Sioux gave NASA moon stones before they went to the moon.
Oh, that is so
right.
cool.
And the Smithsonian had them, so you can look this up. And then the last source would be, of course, the very, very controversial story of Tiamat being hit, and that would be us, being hit, and then the moon that used to be here destroyed, becoming the asteroid belt, or the what was it called, the belt of Anu.
Yes.
And that asteroid belt being formed, and possibly maybe it was even 2 moons, because there's 2 different groups in the asteroid belt and they move around. I think it seems pretty likely that our moon swung near. There are 2 South American tribes. You can check this out in Fingerprints of the Gods. And there are 2 South American tribes which say that it was the moon that caused the Great Flood. So this body coming close to us, coming close enough to cause discharge and then move around.
Control all of the, the tides and everything. So that would make sense.
And it's facing us. Its same face all the time indicates there was probably an electrical attraction between Earth and just the same as Pluto and Charon.
Yeah.
And that coming together. So I'm working through right now. I didn't bring it with me, but I'm working through a super timeline that uses the different gods of the different places. At some point, I will read the whole Mahabharata to try and put it together. It's funny because they made their own Star Wars. The Sumerians and the Indians made their own Star Wars out of this stuff. I mean, they turned it into stories because it was huge on their mind. The Bible's probably the more condensed one. When you talk about Exodus, is like the condensed version.
Yeah.
And then, of course, the Lakota Song of the Destruction.
Let me check and see if we have any questions and do a couple more shout-outs. Hey to Ellie and Jerry and Jennifer and Angie. Oh, special shout-out to Michael James Warrior. Thanks for joining tonight. I hope you're doing okay. James, Mary Cummings, Matt Johnson, Billy, Greg, Caitlin, Christy, and Ricky Elkins. Kisses to you, Ricky. Thanks for joining me. Andrea, Tim, and Pam. Yeah. So if any of you guys have any questions on my personal page, please put it in the comment section. We'll go back and address those. And so let's start to wrap up.
Where do we go from here?
World Testimony of Catastrophism and Strange Human History.
I really recommend people read Worlds in Collision. It's a mind-bending book. And you don't have to.
Plenty of patience.
Yes, Immanuel Velikovsky brought together, and it's all cited. Right? So in the book, it's cited. So it's not just him saying some words. I mean, it's citations from different scriptures and different places around the world, different faiths. Worlds in Collision, of course, we talked about in the Velikovsky Conundrum, is the book that they attacked him before it was even published. I forgot to mention that.
Oh.
They started the campaign against him 6 months before it was even out.
How did they know about it?
He made the unfortunate, so this is why I want people to know Art of War is incredibly important. He unfortunately sent a manuscript of a chapter to the Harvard, to the head of the Harvard astronomy. This is the guy that thought the solar system was the universe, and Hubble defeated him. So he had an axe to grind with the world, and he made it his personal mission to destroy Velikovsky, and he just about did it.
That's such an evil act.
It was very, very wicked, and this guy was a kind of a moron. So it's just the way things go sometimes. But Velikovsky's book holds up pretty well. I was looking through it. I mean, there's a few things that are new and updated. However, it's an amazing work, and I think people should read through it. And then feel free to look at Carl Sagan, what he says, and then feel free to look at the PhD thesis that I posted.
If people want to know more about the plasma electric universe, they should start with the Thunderbolts project.
That and
then
well, they
go
should
and
start with the
read
electric. They should start with My Electric Universe Gateway, because
Okay,
the
well-
gateway goes to Thunderbolts, it goes to Sky Scholar, it goes to Suspicious Observers, it goes to alternate, even more alternate than them. You know, new electromagnetism. I mean, all sorts of really great stuff. I keep posted videos, and then I have the Electric Universe primer we made after
Yes.
the episode 1 posted right on the front of the page.
And I will put that in the comments
Yeah.
section for you guys. One of us will. And you can just take that link and benefit from all of Sifu's
Yeah.
hard work. And it will get you where you want to go on information or
Right.
whatever your questioning mind wants to hear. Now, before we go, because we're out of time.
Yeah.
So, look, we're out of time.
It's so sad.
I want to ask one more thing. What are your latest events going on?
Well, I got all sorts of things going on. You're going to have to pronounce the one, but on the 28th, I'm supposed to speak about Chinese stuff.
Yes, and then that's on the 28th at 11 a.m. at Rock House Brewing. Sifu will be speaking to the Lexington Samhain celebration. And what is it you're going to talk
I'm
about?
going to do demonstrations of
Oh,
Chinese,
fun.
of Gung Fu. I'm going to do sticking hands with anybody that wants to come up and touch hands. And then I'm going to be speaking about Chinese medicine and alternative health, you know, modern health. And I'm also going to speak about Zep Tepi. I'm going to actually start talking about the origins of, you know, at this point, we're all pretty certain, if you're watching this channel, probably you're certain the system's been lying to us. Well, I'm going to talk about a way for us to move kind of around that.
Yeah, we have to.
yeah.
Inquiring minds want to know.
Right, and I don't know, I'm sure everybody else here is tired of us, our side losing, so I'm going to be talking probably about how do we achieve the royal sway. Because achieving the royal sway that's a technical term in Art of War, is absolutely fundamental to the survival of mankind at this point. It's absolutely, we have to win, and having to win means that we have to learn how to play the game. And when you're playing a game where you've been given all the pawns and they've taken all the power pieces, you got to learn some leverage points. You got to learn the technology of sure.
Thanks for the hearts on that.
And then I'm also doing, of course, I'm going out to see Graham Hancock speak, and then I'm doing, you know, I'm traveling over, looking for stuff all over Kentucky still. That's nonstop with me, and people are invited to come with me for some of those things.
So, and if any of you are interested in all of this, I'll put some links to Sifu's YouTube channel and the Blue Lotus Acupuncture site in the
school.
comments.
Come by and see the school. Yeah, come see me at the school. We talk about really cool stuff.
Yeah. So we will see you guys next Monday, or I will. And okay, one last thing. What's for dinner, David?
What's for dinner?
What's for dinner? David is back in the swing now. He's all well. I got him all healed up.
I'm all well. We're going to have Kain Kwa.
Come in.
We're going to have Kain Kwa.
And no one knows
Thai.
what that is.
It's a Thai curry, type of Thai curry. It's got chicken, bamboo shoots, and then whatever other little vegetables you want to add. We'll have that with jasmine rice.
Yay!
It smells amazing.
It does smell amazing.
I ate already, but it
right.
smells
Kisses
amazing.
from
I know,
Kentucky.
I'm a little bit.
And I will
Thank you,
see you
guys.
guys next Monday.